All right, welcome to Data Science Club number 22. This time around there are a couple of libraries you'll need to install. So we just took a video for just the library setup part so that we still capture that. So if you need help with your libraries, take a look at that video. Or listen in on that, and then come to this one next.
Yeah. So this would be the second part of the series. So go through the first one, and it's a series of only 2 videos. So
yeah. We're gonna start trying to do this where we separate out the environment setup into its own video, because it's really important to capture that. Because a lot of times it is a little bit tricky to get all that loaded up. But at the same time, we want to make it easier for you to access just the portion of the content where we're talking about algorithms and doing stuff, if that's what you want to do.
Yeah.
With that, today we're going to be talking about starting and stopping training of machine learning models in Keras. And Ravi picked out this topic. So Ravi, do you want to say a little bit about why this is important?
Yeah, I mean, so the article that we are going to be following for the starting and stopping in Keras is an article on image search, and basically someone asked the author of about a question like they work on a shared environment, and the user who asked the question, they only got access to GPUs for about a couple of hours at a time. And so he wanted to know if he could checkpoint his model to that particular time so that if after 2 hours his neural network model hasn't completed successfully or hasn't completed, then he can take a checkpointed version of that model, and the next time when he gets allocation again on the GPUs, he can begin the process from where he stopped last time, rather than beginning from the start and then again failing after 2 hours.
This is really helpful, especially like Ravi said, for shared environments, and also just it's something you should do. It's like saving a Word document when you're editing it. If you don't, you might lose all of your work. Even if you own the computer, the power might go out and the battery might run down on your laptop, and then your model is just lost. But if you're doing checkpointing, then if something happens, you still have the most recent version of your network saved, which is really helpful.
Yeah, and eventually, I mean, further down in the article, the author would give another good reason for using the start and stop functionalities is like if you are keeping a track of how your model is doing and you see that your accuracy rate is not going to the point where you want it to go, like generally above 90% is kind of good, and if your model is just lagging around in 70%, you can pause or cancel your model at that time. You have a checkpointed version, and then you increase your learning rate or introduce some other modifications that might be useful to increase the accuracy rate.
Yeah, and there are certainly ways to automatically modify your learning rate as it's going along, but a lot of times a priori or before you're starting your model, you don't actually know what those things are.
Yeah.
So with that, let's hop in. So it is this Keras starting and stopping and resuming training. And we're using the Keras library to do this, and with the TensorFlow backend. So before we get that going, let's start up our environment. We're going to come onto the Chiha computing platform we have here at UAB. And we're going to go to, and that's at rc.uab.edu. If you're at UAB, you have access to this. Just send us a comment or something if you don't have an account, and we'd be happy to help you with that. If you're not at UAB and you're doing this on your own system, then the primary thing you have to have installed is Anaconda. in order to use Jupyter notebooks. And so that's because that's what we're going to use here. On rc.uab.edu, we're going to start up a Jupyter notebook. And this is what that's going to look like. So we're going to tell it to go to our Data Science Club folder. We're only going to ask for 2 hours, but we are going to ask for the Pascal nodes partition because on Chiha, those are the ones that have GPUs associated with it. And then we'll ask for 4 CPUs and 4 gigs of RAM per CPU. So that ends up being like a quad core machine with 16 gigs of RAM.
Yeah.
So I actually have already launched one of these. So rather than launching one now, I'm going to come up to this little icon here, which will show me what I already have running. And I'm going to connect to Jupyter. All right. So now what we're going to do is in the video just prior, we actually downloaded this Keras Start Stop Resume folder. And so we're going to go inside of there and we're going to create a new Python notebook using the Notebook of the Week environment. And then we can get going. So let me make this full screen. And then I'll double panel. All right, so let's just scroll to where the code starts. They have some nice visualizations about training.
Yeah.
Let's keep on going. And this is where they talk about learning rate schedulers to improve training. So definitely read through that if you're curious and you want to take a look more at it.
Yeah, and that is one of the methods of the one that I was mentioning, the second advantage, where you can stop it and change your learning rate and stuff. That's what the learning rate decay does. So,
and if you've downloaded this folder, then this is the tree structure of that folder, and you'll actually have this train.py that has all the functions in it. But we kind of want to see how long this is going to take and whether or not we're going to crash something by doing this in a Jupyter notebook rather than a Python script. So that's what we're going to do. So first things first we got to import libraries. I'll copy paste that. Now this second line here, the matplotlib use ag, that's just to make sure that if you're plotting things, it's not looking for a display. Since we're in Jupyter notebooks, we can actually comment that out because we want to see our figures. Then under here, these PyImage search libraries are actually the ones that are just inside of that folder that we downloaded.
Yeah, and that's also a method of denoting folders, the dots that you see. Mm-hmm. So there is that PyImage search folder where this library is. If we can go back to the directory structure.
Oh yeah, I can actually go over here.
Yeah, so there is this PyImage search, that's the first character, and then there's dot, I think callbacks was the first one. Yeah, callbacks. Oh, I can see it from here. Right. Yeah, and then there is this epoch checkpoint.py.
Yeah.
So this is the first one that we are calling, if you see.
Yeah. And that's a really good point. I actually remember the first time that I encountered loading Python libraries.
Yeah.
And there is not easy documentation to get to somebody explaining that.
Yeah.
So I know that it's been personally frustrating for me.
Yeah.
So just to kind of repeat, because it's an important point, if you're building functions in a Python file, you can actually build this directory structure into your code, and you can develop functions outside of your main code and use them simply by just using this syntax of saying from whatever the folder name is with the modules, and then add dots for the full path until you get to the final file, and then you just leave off the .py at the end.
Yeah, and in this one we are importing the entire class epoch checkpoint, at least in the first one, and that means that you are getting these two functions of the init and the on epoch end. I'm pretty sure we'll be using this on epoch end somewhere in the end.
Yeah, and an important thing to recognize in this code, since we opened it up, is that this isn't doing anything particular to PyImage search. This is all just Keras stuff, but they've just abstracted it away from us a little bit by putting it in this folder. So you don't have to have these libraries to create this checkpointing stuff. It's something that's actually built into Keras, and these just abstracted away a little bit for us. So we don't have to fiddle with it.
Yeah, I just wanted to make sure so that they know that, PyImage search is at a different library that they're pulling. It's just a folder structure from which we are pulling things.
So there's the PyImage search libraries are the ones specific for this project that are in that folder. Scikit-learn we've used before for doing some machine learning stuff. It looks like here we're using a pre-processing thing for this model.
Label binarizer.
Yeah, so I think this is on a fashion MNIST, so it's recognizing like shirts and shoes and things like that.
Yeah.
So I think the label binarizer is just a way of encoding the names of the different images. But we'll see. I could totally be wrong. Let's see. So we're going to use stochastic gradient descent for our optimizer. That's what this SGD is. Image data generator is really nice. It's a way of importing your images batches at a time instead of all at once, and it enables you to not have to store your entire data set in memory. Data sets import fashion MNIST. So that's the data set. If this were a normal real world project, we would just import from a folder. But here this is built into Keras, so we can just use that. And then models import load model, and that's what's going to let us start back up again after we've stopped.
Yeah, I was about to mention that's an important library. It's basically saying that if you can find a model already, then you can use this load model function to load that model in your environment and just begin from there. That's what they're going to use for checkpointing, I'm pretty sure, at the end.
Yeah. All right. So this next block of code is probably going to break inside of the Jupyter notebook because this is parsing arguments. Yeah. And we don't have arguments here. So what you can actually do is just, so we'll comment it out. All right, so we're going to comment that out. And I just did that by highlighting the whole block and then using 3 single quotes. And Jupyter automatically puts 3 single quotes at the front and the back when you do that, which is really nice. And then what this is going to do is going to create these different variables. So we'll just create these with the same defaults. So we're going to say checkpoints equals true. Oh no, so this is the path to the output checkpoint directory. Which I think is, let's see, so it's going to be under data, user, WS Monroe, RC-DSC, and then Keras, StartStop, resume. I gotta expand this out a little bit. And then under output. Okay, so that's where we're going to store our outputs. Model, so path to the specific model we're trying to load. This says it's optional. Okay, so we won't worry about that right now. It might become more important later, but I don't know. And then epoch to start training at. We'll just go ahead and put these in as something, and then maybe we'll come back to them. Since our checkpoints are going to be stored here, that's probably where the models are going to be stored. And then start epoch. Let's see, I'm trying to remember how that gets converted. Underscore? I think that turns into an underscore. So when you have arguments in Python, these hyphens get turned into underscores for when you're actually running it. But we'll see later. They'll reference them and we'll get to edit it and make sure. So we'll just say we're going to start at epoch 1. All right. So let's go down a little bit more. All right. Okay, so now we're going to grab data. So let's copy that and paste it in here. And what this is going to do is first it's going to download this MNIST data with this function, and they've already split this up into training and testing data sets for us, which is nice.
Yeah.
And then on top of that, the model that we're going to be training is expecting 32 by 32 images, but these are 28 by 28. So we're going to run this command, this cv2. So computer vision, this is a computer vision library, and we're going to resize the images. So this is a one-line for loop. Okay, so it's saying for x in train x, which this is train x up here, resize it to 32 by 32, and we're going to do that for training and testing. And then we're going to rescale between 0 and 1. A lot of neural networks work a lot better when you've normalized your data, so that's what that piece is about. And then also generally the neural networks are expecting a specific dimension. So they're expecting, in this case, because we're looking at images, even though the images themselves are two-dimensional, Keras is expecting a 4-dimensional array as its input. So it's expecting the first dimension is going to be the number of samples, and then the second two are x and y, and the third is z. So if you had a color image, it would be 3, but these are grayscale, so it's 1. All right. And now, let's see. So this next piece is on binarizing our labels. So let's take a look at this. Okay, so it's taking in our Y data set, which would be the numbers associated with each label, and then turning it into a one-hot encoding, I think. That's what's going on there. Easy enough. And then this image data generator, actually we're taking, here it's not specifying any data at this point, but this allows us to pipe through our trainx data set through these augmentations to help improve the generalizability of our model. So it'll wiggle the image up and down and left and right a little bit, and then every now and then randomly flip it horizontally, so that the network has to learn what a shoe really looks like, whether or not it's heel first or toe first, and that kind of thing. All right, let's take a look at what this next piece is. All right, what's going on in here?
So this one asks if the argument that you passed in model is none, then it's going to begin from the start. Else it's going to load the model that you specified that it should start from.
So I actually broke it because I specified the model.
Yeah, so if you just left it as blank, I guess it should have.
But now that I've done it, it's still going to retain that value. So let me change this, I think, to just an empty array.
Yeah.
Let's see if that works. So at this point, we've defined model. So now if we go back and ask it to do that, it's going to give us the same value every time, even if I take model out of here.
Yeah, I mean, one of the hard-coded method that you can use for this is if you go to kernels, I think there is an option where you can. I think it's just basically restart and run all.
Okay.
So that's going to take out all the variables that you have saved.
Yeah. All right. Oh, name args is not defined.
Yeah. So we might have to just take out the else option or comment out the else option for now.
Well, what we can do is actually here, because args
yeah.
is not defined. So that's the other issue.
Yeah.
Okay, so this is because we're not doing this on the command line. Oh, and again, that's in the else. I think we are going to have to do a restart and run all so that we can get rid of our model variable. Because even making it an empty array. I guess I could just assign it to none.
Yeah, I think that might be better because it still expects us to see model.
Yeah. So let's do that. All right, we didn't get any problem there, so let's go back down. Hey, there we go. All right, so this ResNet.build function is abstracting away the actual building of the neural network, and it's making it seem like it's doing something really kind of intense based on this information. But I think basically what's going on is that it's saying, okay, these are the dimensions of my image. So 32 by 32 by 1. And then the rest of these, I'm not really sure. Reg, I think, is regularization. We can look at what that function's actually doing. It's probably just calling. Oh, okay, so this is actually building a ResNet from scratch. Huh. All right, so inside of Keras, you can actually just pull in a pre-trained ResNet to use, which is what I would do in a normal situation, but it's kind of nice to have access to these codes that are building it from scratch. But these are the values that one's looking for. So it's looking for width, height, depth of the image. So those are all the image dimensions. Classes is the number of output classes we're looking for. So in this case it's 10. Stages, filters, regularization. All right, and I think that's all pretty good. And data set equals sci-far. I think they've got some maybe some default weights that you can bring in, but I'm not sure that I see where it's pulling in the data set.
So generally what is ResNet used for? I mean, if someone is supposed to use the model ResNet, what would be kind of a problem set where they'll be using it?
So ResNet is used very commonly for image classification purposes. So sci-far is an image classification database. ImageNet is another image classification database where you have in ImageNet you have 1,000 images for 1,000 categories, and ResNet is one of the best networks to get really high accuracy on the ImageNet images for classification. And so it's a really nice network. It trains faster than some of the more standard, just kind of pancake layers neural networks where you just have one layer after another. What happens is in ResNet you have a whole bunch of layers, but then every now and then you get kind of skip connections from early in the model to later in the model, and it helps bring those just kind of feed forward some residual feature information to later in the model to make your prediction and your training go faster. So we don't have to get into exactly what this the structure of a ResNet is, but it's a really nice neural network. And if you don't know where to start, it's frequently a good place to start when you're looking at an image classification problem.
Okay.
So I've used it for brain images, like somebody Parkinson's disease or healthy. I've also used it for spectrograms of animal sounds, like what type of animal is making this sound. And so yeah, it's a nice place to start if you don't know where else to go. All right, so we've compiled our model, and then now we're going to develop our callbacks. So a callback is something that the model refers to help inform how it's going to train in the long run. All right, let's see. Args is not defined, so that's fine. We'll take that out. And then that would see, let's see, it says args checkpoints and then args start epoch. And we're going to take all that out. So there's just says checkpoints and start epoch since we're inside of a Jupyter notebook. Let's see. So this is nice. So we're gonna, all right, so we've got two things going on here. We've got a plot of how the training's going that we're gonna save out. And then we also have our checkpoints that we're gonna create. And so that's the two callbacks that we have. Is we have one that's going to take checkpoints starting at the start epoch, which in our case we just assign that to 1, and then it's only going to take a checkpoint every 5. There are other versions of this callback I've seen where it just takes the most recent one, so it does everyone. I've also seen them where they take the best. So maybe you're training for 50 epochs and the 48th epoch actually had better accuracy than the 50th one.
So you just keep a copy of that 48th one, and discard the 49th and 50th one.
Yeah.
Okay.
And then let's see, this training monitor is going to save our training information out so that then we can, and apparently it looks like it's also going to save out the image for that. So let's try that. All right, so that worked now. And then now we're going to train the network. And so as we saw last time with the GAN, using Keras to train a network is really pretty straightforward. So it's this model fit function, and when you're using a data generator, you got to use the model.fit_generator. If you're not using a generator, then you can just say model.fit, and it'll work on that. And then what we're going to do is we're going to call the image data generator, which was this augmenter, with the .flow, and so this is going to feed the model batches of size 128 of the images into the model, and then update the training based on that. And then probably at the end of every epoch, it's going to run this validation data. So it'll use our testing data to actually check how well we're doing on the network. And it says we're going to run 80 epochs. I think since we're doing this live, we're going to change it to 20. Let's change it to 10. If this runs in like 5 seconds, we'll increase it. We are running on a GPU, so that should help out quite a bit. But let's see.
It looks like 5 seconds per. Actually, more than 5 seconds per epoch.
Yeah, it looks like when they were training it, it took 200 seconds per epoch. So we'll see how this goes. I would expect that it's hopefully going to be less than 200 seconds. But that's the beauty of what we're doing here. So we might actually cut it off and just check and see whether or not our checkpointing is working.
Yeah.
All right. Yeah, because how many images were in that MNIST data set? Is that 4 million? Am I reading that right?
Yeah.
Okay, that's a lot of images.
Yeah, 4.5 million is a lot.
All right, so on the plus side, this is the power of GPUs, is that it's taking much less than 200 seconds to run an epoch. So let's see. So it's got a checkpoint that
79 seconds.
All right.
This
So
might
that
be
was-
faster. I think first one took longer to.
Yeah, the first one generally does take longer. So let's let that run for a little bit.
Yeah, maybe around fourth or fifth we'll stop it and change the model and
Mm-hmm.
begin again.
Yeah.
Oh, actually, we are taking only every fifth is going to be checkpoint.
Oh yeah. Let's see if it actually checkpointed the first one. So let's go back into our folder over here.
Output,
We'll look in output.
checkpoints.
Checkpoints. Do we have anything in there?
No.
Doesn't look like we've got anything in there.
Why isn't it opening up?
I don't know why it's not opening up. Let's look at it in the terminal. Oh, of course. Takes me back to the home directory. C-DSC, Keras, start, stop, resume. And let's look in there. All right. So we're going to go into checkpoints. And there's nothing in checkpoints. So yeah, so we've got to wait until the fifth epoch to get a checkpoint.
Yeah. And then we'll stop and start. It looks like, oh, this one was super fast. Oh,
Well, the previous one was 57 seconds.
so less than a minute.
But already, even though we're only doing 3 epochs, we're to 80% training and validation accuracy.
Yeah.
That's not too bad. All right, so now we're on our 4th epoch. The 2nd and 3rd epochs both took 57 seconds. On the GPU, if you're running this on a CPU, I would expect it to take the full 200 something seconds. So probably almost 4 or 5 minutes to train every epoch. These are really tiny images, but
Yeah, a lot of them.
there's a lot of them. So yeah, let's see if, okay, so we can see their training accuracy here. Let's compare ours. So it looks like at epoch 3 they had 86% training accuracy.
Ours is 86.5, so.
Yeah, so that looks about right. But our validation accuracy was less.
Oh, we did well in the fourth one.
But yeah, and then the 4th one, it looks like we're back up to what they're expecting. And then yeah, now we're about to start our 5th epoch.
Is it saving a checkpoint at fourth? 5 second, third, fourth. No, fifth should run, right?
Yeah, the fifth is the one that should be taking a checkpoint. It hesitated there for a little bit. I'm not sure why. Maybe it's just because it's a lot of data.
Yeah. Just to make sure, can we go to that file explorer, the terminal?
Yeah.
And just-
Yeah, so there's nothing in there at this point.
And we expect after this one, once it starts the 6th one, there should be a checkpoint model.
Yeah. Which, even if it seems like just a little bit of a pain to get this checkpointing going, I would highly recommend that anytime you're working with a model like this, that you do checkpointing, because even though it's a pain to set up, it's not even really that much of a pain to set up. And it's like saving your documents. It's like doing GitHub. When you need it, you're going to want it. And if you didn't set it up, you're going to be really sad. All right, so we passed by our 5th checkpoint, or our 5th time. Oh, you know what? I think I may not have gone all the way into...
There is the epoch file.
There we go. Yeah, so when I set the checkpoints folder, I just told it to do output. I didn't say output/checkpoints.
So if you see epoch_5.hdf5, that's the model after the 5th epoch. Yeah. Now what we can do is we can cancel out the job, and
so I can stop training,
and we can go,
and then let's see, so phase 2, so now I can specify my model, right?
Yeah, you can specify model.
All right, so let's see.
So rather than model equal to none, it would be...
I can go model equal to, and then put that epoch 5 file there.
And we'll start our epoch from
5? Or
6.
6? Okay. All right, so we're going to do that. We don't have to reload our data set because it's already loaded. We don't have to rebinarize stuff. We do have to reload our model. Okay. All right, so this is because earlier we didn't run this side of the function. All right, so we can take out the args model because we're just looking for just model. Okay, sweet. So it's actually loading our neural network weights. So the beauty of this is if you get pulled into a meeting, if you have to stop training, you have your work saved, and then you can come back and start training from this same spot.
Yeah, I mean, going a little off topic, if you want to know, this loading functionality of loading of a model is useful if you want to know what to do with your model after you have trained it. Like if you were running a neural network of finding a cat, you have some training data set in which you are dividing stuff into validation and training, but ultimately you want other people to let use your application so that they can see if the image that they choose is a cat or not. For that, you take out these models and actually use them in Python or anywhere else, and call them and create applications out of these models. So.
Yeah, and that's exactly right. This is actually the same exact process that you use to save out your final model.
Yeah.
It's just there's another more official function to save out your final model, but it's the exact same file format. And so it's nice. This function that we used to load in our model is interesting because it also updates our learning rate to 10 to the minus 2 instead of 10 to the minus 1. And so this is touching back on that other reason why you would have starting and stopping, is because maybe you realize that you've hit a plateau, so you need to decrease your learning rate so that you can better find the optimum with the gradient descent. All right.
We'll need to run this too because we changed our epoch.
Oh, yeah. Okay. And then let's try this. Okay, so you notice that earlier our accuracy started at 70%. We can look because it was very similar to what they had over here. So our accuracy started at 70%. And now we're restarting training, but we're starting with a pre-trained network. So our accuracy is starting at 90%. So that's good.
Yeah. The one thing that I'm surprised is we are starting from epoch 1 again.
Yeah, I think it always starts you from epoch 1, and that start epoch is just, I'm not really sure why we would specify that differently. That I think it's from where you're going to start taking the checkpoints and where you're going to start doing the training monitor.
That's true.
So here, since we specified 5 as the start epoch, we might not get another checkpoint until we hit 10.
Yeah. Alright, let's see the PNG image that's...
Oh, yeah.
That's checking our training.
Alright, so we're going to go to Files, Data User, RC-DSC, and Keras StartStop Resume, and then Output, and we're going to view this PNG file. So it may be possible that we're also supposed to continue or to switch that start epoch so that we're not overwriting this file but extending it.
Yeah.
Because we didn't actually make it to 6 epochs previously.
Yeah.
So maybe it's just adding in the new information there. But this is how our training's going. So far we've only done 6 epochs. If we look at their figure, they do 40 before they look at it. So it makes sense that we're not getting...
Yeah, initially if you see it as for the initial phase, it looks very haphazardous for them too.
Yeah. Yeah, and it generally will start fairly haphazard like that. I wonder, do we make it to... Alright, let's see if it updated that file since we made it another couple of epochs. Okay, so it says epoch 7 here. So it looks like it's updating. But we'll have to check that out later. But more or less that's how you start and stop. It's a really helpful thing to do. And if you have any trouble with it, you just let us know. Come on in and check it out. On Chiha, we only allow our GPUs to be used for 12 hours at a time. And so we really, really highly encourage folks to do this checkpointing. Because if you're training a really large model for a long period of time, there may be some hazard that causes the cluster to shut down, or you may just have not planned out your training as well as you thought you had, and it's going to take more than 12 hours, and you don't want to lose all that work because 12 hours of training takes 12 hours.
Yeah, and we don't want you to lose your work as well, because that's the computational power that we have already spent in getting to that stage, so why waste that? Yeah,
exactly. But yeah, that's pretty much it. So yeah, if you have questions, come in and talk to us. This isn't necessarily as exciting of a pure data science topic, but if you're doing these things in practice, this is super important.
Yeah.
So yeah, definitely take advantage of that. So yeah, anything else, Ravi?
No, that would be all. And yeah, I mean, if you have any questions, like William mentioned, send us an email, post a comment, or just come to the office hours.
Yeah, sounds good. We don't bite, or at least we try not to.
Yeah.
All right. Well, yeah. Until next time. Have fun, guys.
Yeah.
Bye.